CompTIA Cloud Plus, Event-Driven Architecture. Event-Driven Architecture, or EDA, is an architecture driven by events that leverages occurrences to initiate actions and facilitate communication among loosely connected services. This approach is prevalent in contemporary applications designed with microservices. Microservices are often the functional components of a container that's packaged with Docker in an agile or CI/CD lifecycle. An event signifies a transformation in state or an alteration, such as an item being added to a shopping cart on an online marketplace. Events may encapsulate detailed information, such as the purchased item, its cost, and the shipping address, or serve as mere indicators, for example, a notification confirming that an order has been dispatched. Here's a diagram courtesy of Amazon Web Services. It's an example of an event-driven architecture for an e-commerce site. This architecture enables the site to react to changes from a variety of sources during times of peak demand without crashing the application or over-provisioning resources. Notice that you have an event producer in the upper left-hand corner. That's the retail website, along with a mobile app, which is what the customer uses to submit the question about availability of an item, and then the POS system, the point of sale. In the middle is the event router or event router. It ingests, filters, and pushes the events to the appropriate consumers. For example, warehouse management databases, finance systems, or customer relations. Event-driven architectures are ideal for improving agility and moving quickly, and they're commonly found in modern applications that use microservices as mentioned, or any application that has decoupled components. Some of the benefits of EDA is that they scale and fail independently. By separating your services, they interact only with the event router rather than directly with each other. This ensures interoperability while maintaining system resilience. So if one service encounters a failure, the others continue operating unaffected. So the event router serves as a flexible buffer, efficiently handling workload spikes. Also, you can develop with agility. You don't have to keep writing code for polling, filtering, and routing events. The event router takes care of it automatically, delivering filtered events directly to consumers. Also, the router eliminates the need for complex coordination between the producer and consumer services. This streamlines development and accelerates your workflow. Also, an event router serves as a centralized hub for auditing your application and enforcing policies. These policies can regulate who is allowed to publish and subscribe, as well as manage user and resource permissions for data access. Additionally, you can secure your events with encryption both during transmission and while at rest. And then cut costs. Event-driven architectures operate on a push-based model, triggering actions as soon as an event appears in the router. This eliminates the need for continuous polling, reducing cost associated with network bandwidth, CPU usage, idle fleet capacity, and TLS handshakes. Some common cloud service provider EDA services would be Amazon Event Bridge, a serverless event bus that connects applications using events from AWS services, SaaS applications, and custom sources. Google Cloud PubSub. This is a messaging service for event ingestion and delivery, supporting real-time analytics and event-driven applications. Amazon SNS, Simple Notification Service. This is a messaging service for high-throughput, low-latency events. There's Azure Event Grid, a fully managed event routing service that simplifies event-driven architectures in Microsoft Azure. And then finally, Apache Kafka, a widely used open-source event streaming platform for real-time data processing. I hope this video was informative for you. Thank you so much for viewing.